In behavior of gases, there are many laws. The Dalton's law is the most important law of partial pressures. Now, if two or more non-reacting gases, means non-reacting means which do not react, like if Dalton law is not applicable for the reacting gases, it is applicable only for the non-reacting one. Now, non-reacting gases are enclosed in the container, then the total pressure of the gas is in the container is the sum of all the partial pressure of the gases which are enclosed in the container. Now suppose there are three gases, so PA plus PB plus PC, and if there are more than three gases, then the sum of all the pressures of the gases gives you the total pressure of the gas. Now how can you find out the partial pressure of the gas? The partial pressure of gas is equal to the mole fraction of that particular gas multiplied by the total pressure of the gas, which is like total pressure of the gas enclosed. Now suppose let us take an example, like equal volume of O2, SO2 and CH4 are enclosed in a balloon. Now if a small hole is present in the balloon, then after 15 minutes the partial pressure of the gas present in the balloon is in which order? Means you have to find out the ascending or descending order of the partial pressure of the gases. Now since the rate of diffusion, as we know that it is inversely proportional to the molar mass, as we have studied it in Dalton Graham's law. Now molar mass of CH4 comes out to be 16, molar mass of O2 comes out to be 16 to the 32, and molar mass of SO2 comes out to be 64. Now since the rate of diffusion is inversely proportional to the molar mass, volume of the gas enclosed will be in the ratio volume, like CH4 will have maximum volume. Why? Because it is having lesser molar mass. So volume of the gas diffused out is of CH4 is greater than O2, which is greater than SO2. Okay, now according to Boyle's law, since the pressure is inversely proportional to the volume of the gas, now pressure of SO2 will be greater because the volume is very much less. Now pressure of SO2 is greater than O2, then it is greater than CH4. Now this is the relation. Okay. Now let us take another example, like a mixture of C3H8 and CH4 exerts a pressure of 320 mmHg. Now at temperature, suppose any temperature like T Kelvin and volume V. Now on complete combustion, if we burn any hydrocarbon, that it gives out carbon dioxide and water. Now it gives out only carbon dioxide. If we burn C3H8 and CH4, it gives carbon dioxide only. Now it exerts a pressure of 448 mmHg. Now we have to find out the mole fraction of C3H8 in the mixture. Now since first we take out the let us take the number of moles of C3H8 be N1 and CH4 be N2. Now as we know that mole fraction is the formula, like number of moles of any gas like C3H8 we take as 1 and CH4 we take as 2. So number of mole fraction of C3H8 is equal to number of moles of C3H8 over number of moles of C3H8 plus number of moles of CH4. Now partial pressure of this is equal to N1 plus N2 over V into RT. This is an ideal gas equation, as we know. Like total, if we have a mixture of gases, now the total pressure is given like 320. 320 is equal to N1 plus N2 over V into RT. Now as we know, according to the equation, now C3H8 gives 3 moles of carbon dioxide. When we balance the chemical equation of C3H8, when it burns in presence of oxygen, it gives 3 moles of carbon dioxide. Now CH4 gives only 1 mole of carbon dioxide. So N1 mole will give you 3N1 moles of carbon dioxide, and N2 moles of CH4 will give you N2 moles of carbon dioxide. So in this question we have given the two conditions. First we are burning the mixture of hydrocarbons and we are getting it exerts a partial pressure of 320 mmHg. So that we have calculated, like partial pressure of the mixture of gases comes out to be 320 is equal to N1 plus N2 over V into RT. Now in second case we burn them and the carbon dioxide exerts a pressure of 448 mmHg. Now carbon dioxide is 448 is equal to 3N1 plus N2 over V into RT. If we divide both the equations given, like 448 over 320 is equal to 3N1 plus N2 over N1 plus N2. The two conditions which are given, if we divide both the conditions, we can calculate like N1 is equal to 0.25 N2. So now we can find out the mole fraction of C3H8, which is equal to 0.25 N2 over 0.25 N2 plus N2, because N1 is equal to 0.25 N2. Now mole fraction of C3H8 comes out to be 0.2, which is required in the given question.